Good evening, guys, and welcome back to 2.6, where you're looking at transforming equations, part 2. Remember, we're dealing with literal equations now, so we're dealing with more than one variable in our equation, and every equation has an equal sign. So let's look at this problem. We're on your note-taking guide, page 41, example 3, and we have the formula, K equals C plus 273.15. And that gives me the Kelvin temperature, which is my K, and it gives it to me in the terms of my Celsius temperature. When you see this phrase, in terms of, then that means that I'm always setting up, in terms of is setting up something on one side of my equal sign and the other. And if it wants me to give the Kelvin temperature, K, in terms of Celsius, then it means that they are on opposite sides of my equal sign. Anytime you see in terms of, it means it's going on the opposite side of your equal sign. Now let's look at what it's asking me to do. It wants me to transform the formula to find the Celsius temperature in terms of, there's that phrase again, in terms of Kelvin temperature. All right, what's different here? It wants me to find the Celsius temperature in terms of the Kelvin temperature. Then, thens are important. Then I've got something going on here. Then I need to find the Celsius temperature when Kelvin is 400. So this is asking me to do a third step where I need to find what C is if K equals 400. Okay, let's break this down one by one. I already have the blue. I've got Kelvin temperature in terms of Celsius. I have to add 273.15 to my Celsius to get my Kelvin. Now it wants me to transform it into my green, where I have C equals by itself. So how do I transform this to get C by itself? Let's get through our 5 steps, of solving multiple steps equations. The first one is to get rid of decimals and fractions. Well, here it's just something that's being added, so I'm going to leave my decimals alone for the moment. The next thing to do is to get rid of my distributive property, which I don't have, then to combine like terms, which I still don't have. Okay, so the third thing I'm going to do is to deal with my addition and subtraction, and I've got addition going on here. So I need to do its opposite, which is to subtract. Remember that what I do to one side, I have to do to the other. So I'm going to subtract 273.15 from Kelvin over here on this side, and I'm going to subtract it over here on this side. All right, let's go ahead and simplify this. K minus 273.15. Oh, sorry, guys. That's 1. Equals C. Because now my 273.15 crosses out, leaving just C by itself. So now I know that I can find C equals K minus 273.15. Same thing. I just totally rearranged it. I just give the mirror image. Okay, now I need to work on my yellow part. I need to find the Celsius temperature when Kelvin is 400. So if Kelvin equals 400, I need to plug this in up here for my K. So it's going to look something like this. C equals 400 minus 273.15, and solve for C. Hopefully you got 123.85, which means that when my Kelvin is 400, then my Celsius is 123.85 degrees. All right, now I would like you to check your understanding. I'd like you to do numbers 2 and 3 on page 41. 2 may require you to go back and watch the other video on the part 1 of transforming literal equations. Remember to give me your units for number 3. So am I talking about chirps? Am I talking about minutes? Am I talking about chirps per minute? Good luck with these. Let me know what you think. I will talk to you in class tomorrow.